Hello, welcome to this. Hello, welcome. My name is Shaquille Veldboom, and in this video, I will be designing in SolidWorks the actual electric motors that will be placed in the wheels for my 2040 Vision design project that I gave myself just to kill some time in quarantine. So it's a little bit of a long sentence, but in this video, I will be taking you through what kind of procedures I will be taking in order to make this electric motor to the best of my ability. But I also feel the need to kind of explain to people that maybe don't really have a full realization of how electric motors work, to kind of explain what the general technology is and how it works and the things of the sort. So in this picture right now, you can see an electric motor, which is a brushless electric motor. There's also a brush electric motor, which works on a little bit of a different principle. But this would be the most efficient, also least, I should say, resistant grading version of what an electric motor can be. So here in this picture, you can kind of see the different, the working of how an electric motor would work. So you have an iron core that has copper wires like spun all around it in different fashions that electricity will flow through, creating a south pole and a north pole on every single, on each opposite side. And then you have an outer shell that has permanent magnets on it. So here you can see the South Pole magnet, and here you can see the North Pole magnet. And with electricity that is flowing through these cores, and also with like a controller that can control like the direction of flow of electricity within a core like that, you can create south poles, magnetic south poles and north poles within these coils. And the iron core within these copper coils is supposed to help with kind of guiding and manipulating the magnetic fields to make it work as efficiently as possible. So the next step that you would need to know about these electric motors is that the maximum efficiency of a motor like this would be to have the maximum amount of magnets and the maximum amount of coils that you would be able to fit within this space to have them run at the same time, because all of these kind of empty spaces, even with magnets or like within the coils themselves, would kind of result in a loss of power that you could optimize and benefit from. So that is also one of the things that I kind of use within this project to you know, to guide everything. So first off, I already created a SolidWorks file for everything for this project, and I'm starting off in an assembly. So the file itself, if you wanted to kind of do a similar thing, you would just select new, a pop-up window would open, and you select assembly, and then you're good to go from that point forward. So I already also saved the assembly. I already also saved the assembly, because if you don't save it and you open new components, and which you save in them as like assembly 1, if you then change the title, there are like a couple of problems with SolidWorks when you can change different components and that interact with each other in assembly. So just before you start with the assembly, always make sure to save it. So I already saved it as motor, because this will be like the electric motor and everything for it. And I start off with the front plane, and I use a new part. So you basically, let me do that over and kind of be a little bit more descriptive about everything that I'm doing. So here you can see inner component, and then on the inner, insert components. And then you can insert components that you've already saved, or you can start a new one, a new assembly, or different kind of variations that you want to do. So now I'm going to start a new part. And then you kind of see like a green check mark on your screen here with your cursor, and then you kind of need to select based on which part or on which entity in the part already in assembly you kind of want to base it. So for me, it was the front plane, because that is kind of the plane that I'm going to be using for the wheels and everything. And then here you have all of your draw tools that you can use, and because it's going to be an electric motor that is in a circular shape, I'm going to use the circle tool, and I'm gonna drag it outward like that. So for the electric motor itself, the dimension of it, I want to make it a little bit bigger than you would regularly see like a car wheel, because the bigger a wheel gets, the harder it will be to kind of get into a how do you call it, like a pothole, something, or like an indentation in the road that would create vibrations. So the bigger the wheels are, the more comfortable the car is, but also at the same time you can drive the wheel to less rotation but still achieve a higher top speed. So if you have the power to kind of overcome the resistance that would come with having a larger wheel like that, then it can also create benefit with acceleration and speed like that. So that is also something that I wanted to take into consideration. So for the overall wheel, I kind of wanted to be a 30-inch wheel dimension. So you'll probably have like 2 inches or something of tire on either side. So I will probably make it about like a 28-inch rim. So I would put, because everything is in millimeters too, I would put 280 times 2.54 to kind of convert it to roughly what inches would be, and that would leave me with 711 millimeters, 0.2 I should say. But that is kind of the outer dimension, the outer shell. So then you can select offset entities, and with offset entities you can kind of take the line that you have but then make it either larger or smaller. So in my case, I want to go towards the inside because I don't want to go outside of this border right here. And I'm gonna make it, I think 10 millimeters. Yeah, I think 10 millimeters should be about sufficient. So then I can drag all of that out, and I would have how wide would the tire be? I'm thinking about kind of putting it somewhere like, let's make it like a 305 or something. That is like a regular size. Not that's already like a big tire for sure, but that is kind of sporty and what a lot of these manufacturers use nowadays on these performance cars. So then you can see that it is now 305 millimeters wide, and it is 711, I think, something that it was in the actual bore of it. So this would be the outer stator. So this would be the actual moving component. I shouldn't say stator. This would be the outer moving component, and then we would have still a stator on the inside of it. So this would be where the magnets would be placed, and the magnets would be permanent, and you would have kind of alternating south pole, north pole going on between them. So one of the things that you would need to have is that they are at a consistent number. So at an even number, I should say, because if you have an odd number, you would end up with either 2 north poles or 2 south poles somewhere where they're joining. So you kind of need to take that into consideration, that you always need to keep an even number of magnetic south poles and north poles, and also within the stator, the amount of electronic coils you would have from the copper wires and everything would also need to be an even number. So I always now kind of select this front surface that you want to sketch on, select sketch, and I'm gonna use the front facing. If you select the surface and then select this icon right here, it's normal too, so it will kind of adjust the whole face of the screen and the interface that you're looking at, normal to that surface, kind of perpendicular, I should say. So from the top, I'm gonna draw a small line down, and I think I want to make it about, I think 15 millimeters from the surface or something. I think that would be good. So then it should be 25 millimeters in length, and I can then offset entities again, but then select bidirectional, and I want to make it about a 5 millimeter kind of stud that's sticking out, but because it's selected in bidirectional, it's 2.5 millimeters in each direction basically. So I should also put cap ends, or not, I can do that myself, and then basically draw a line here, and I could cap it off somewhere. I should kind of leave that relation in there, I guess. And then as soon as I trimmed all of those entities off, I can then kind of select, my bad, these surfaces to be selected. If you accidentally hit a line like that, you don't have to kind of get out of the whole extrude mechanism. You can just exit the thin features, and then it's supposed to be good already. And then it's also 305 millimeters, but then in the other direction. So then you would have like a small notch here. But as I said, we want to maximize the amount of magnets that we be able to kind of put in here. So I'm gonna use the circle pattern, I should say, and I can select this feature that we just extruded, and the direction is this barrel shape here, so you can kind of see the preview already of where they would come out to. But like I said, we don't need to put odd numbers, but we need to put even numbers in there. But for the magnets, we could basically put a whole lot in there. So let's try 40. I think that would already be good, but I don't know, maybe even 50 would still work better, I think. So here we have then 50 basically lines that are going across in this whole shape. So this would already kind of be the start of what the whole thing would look like. But this will also be like subjected to change later on, because we still need to make a whole bunch of other components that would be able to fit through this whole process and everything. So yeah, so we will make some changes to this whole barrel design and everything. But so one thing I forgot to do was to save this component. So what I do is right click just somewhere on the component and open it individually. So now it's no longer in the assembly, but it is its own loose identity, I guess. So now you select save as, and then we can go back to the assembly, and now you can see that it is outer rim instead of part 3 from motor assembly or something, I guess. So now we can already go to a new part, and the new part can now be based on this older segment that we have right here. So the new part will basically be the magnets that will be sitting in the actual motor. So that is pretty easy to do. We can select convert entities and select inner loop one by one, and then you can select this outer line to base everything on, and it will show like a bunch of warnings. And I hate that noise every time it kind of comes up, and if somebody knows how to kill the noise, like, please let me know. But yeah, and then you will be able to kind of fit the the magnet that would sit in that place right here to be inserted. So, and also because all of those lines are kind of at an angle slightly like that, they will also be able to like put in place with like pressure or something, and don't even have to worry about kind of putting an adhesive in there or something. You would still be able to do that, of course, but it will keep it in place like that. And then I also kind of drag it out just a little bit to have it just a little bit wider than the regular thing right there. So that is kind of the first basic thing that you would need to do. And here you can also select that you want a circular pattern for this component, and then for the direction you can also select this outer shell. And then for the actual feature, you can now select body and then select just this body. But we could put it at 50 already, but I'm gonna just put it at 25 at this point, because I want to make a north pole and a south pole. So we have then already like all of the north poles or south poles. So something that you could do too is go back to a little bit before the circular pattern, and then kind of put like a plus or a minus in it or something. So you would be able to select sketch, draw a line down the middle, and then use text, use that line, and then select basically like plus. Yeah, and then put it also in the middle again, and then you can kind of see like the plus point right there. I'm gonna make it a little bit bigger though. Let's say 15, but then we also kind of want it to be more centered, but that is too much. Then we can kind of change the line of it. Instead of selecting this to be mid-pointed, let's kind of drag it down. So, and now you would be able to kind of select that sketch and the soft text sketch, and then kind of all of the lines from this, the text will now become a sketch. And you can do that to any type of letters too if you want to have any type of graphics in there. So then you can also take this and kind of do a cut extrude into it, maybe like do it 2 millimeters or something, and then you kind of see the plus always in there. So if you now go back to the pattern, and because we selected body and not just circle, we kind of take this whole body and take that whole process through all of those components. So yeah, I can do either the same for the outer components. I think I'm gonna do it in the same file still, because they don't really come in contact with each other, and for just the overall design process and to keep the file size a little bit down, I think it's easier to just have them as one component instead of doing like negatives and positives to loose into different parts, I think. So what I could do for that was to kind of delete this to make it easier for myself. And for the circular pattern, I would select 50 instead of doing the 30. And then I would just kind of select this surface, click on cut extrude, sketch tool, draw a line like a little bit offset from the center. Again, select the sketch tool, curves that line, and put a plus in it. Again, make it a little bit larger than it was. Let's say 12.5 this time. And click OK. Then we can delete this line again. Select this sketch, or the text I should say, right click it and dissolve the sketch text. So then I can again cut extrude it 2 millimeters, and then I can again go to circular pattern and only select the feature from the cut extrude, and then this will be the outer perimeter, and then it will only be selected 25 times so you can see it that way. And the reason why it didn't work is because these bodies aren't attached to one another, so it can kind of only do it according to one body, I think. But maybe I can select all of them. Yeah, all bodies. I think this would work now. Yeah, here we go. So and now it's kind of the process to repeat with also the mind of the negative poles, I should say. Yes. So now we kind of have a plus and a minus sign on each and every single one of them. So we have our iron core on the outside, and then we have the magnetic shields, like the permanent magnets that would be sitting in place right here. So I'm also give it a little bit of a color to differentiate between the different materials. And let's also already put like materials in. So I have a shortcut on my keyboard that you can just press M and the material library pops up. And the way to do that is within the option menu. Let me show that too. You can put add-ins. Oh, my bad. I think it is customize, and then keyboard, and then here you kind of have a different list of different like keyboard presses that you could put in there. And here you can see like material is selected, and then shortcut would be M. So for me, if I just press M, then I get the material based in SolidWorks and everything. So iron, I don't know if like which one I should take. I'm not like an expert in all of this stuff. It's just that I have a little bit of knowledge on how these things work. And then for like let's put like a polished steel or something on all of these components. So here we have like our outer shell, which would actually be the rotating component. So we would already we would also need to attach like a little bit of a rim barrel to this section that we could actually put a tire on it. And we would also need to attach a little bit of an outer layer that we could actually have also some ball bearings for the inner components to attach to. So I'm gonna do those a little bit later, but for now I kind of want to focus on making the copper internals and to yeah, to basically do that. So I don't know if this is already sufficient a little bit. So also don't forget to go to the magnets themselves and to also save this as a file itself, that you kind of have you know, that's safe too. And so this would be the permanent magnets. So for the new component, we are gonna select again this outer barrel, and we're basically gonna make the copper coils now. So we're gonna make them to be exactly like within this shape here, because they would all need to line up with each individual magnet, because they would be alternating between the positive and the negative every single rotation 50 single times, because it's running across 50 different magnets. So you would need to, you know, optimize the way that these kind of work and everything to be able to deal with those speeds. So the magnets themselves, or I should say the copper coils themselves, the thing that you could do, or that I also wanted to take into the thought process of this whole design, is that they would be metal 3D printed, because you would be able to 3D print with different materials and then kind of optimize the way that these coils are laid out with 3D printing, because it is very precise, of course. So I kind of wanted to make a little bit of a mock-up version and not go too much into detail on how that would be laid up, because to be honest with you, it would be done by a computer at that point, because we can already see today that a lot of computer simulations and different like variations upon products and stuff would be metal 3D printed, and that computers would calculate it instead of having human beings do it. So I think that that is something that the future will definitely like hold for sure. The first thing that I would do is, so I already created a new part, and for that I kind of also selected this surface here again, that it is that surface that I'm going to sketch upon. And then I'm going to just select the inner circle that is, yeah, let's use 300. And then this whole open space right here, that is basically what you will never get to see, I guess. So that is not never get to see, I should say. Let's reverse that, put it at 10, drag the barrel down to this surface, or I should just go blind and select 305. 305. But this will basically be the static component to it. So on this space here, I will select all of the coils and everything to keep the separation between all of the components. So select sketch. I'm gonna make it a little bit, I think this is good though. No, I'm gonna keep it like this. And I want from the surface, I want to have a line that is from this point about 25 millimeters again. And these will kind of be like a little bit of a, yeah, let's call it like an iron shield or something, because I want to make all of these kind of to have them help insulate the magnetic fields and everything. So these are going to be a little bit thinner, 2 millimeters. And again, it's kind of a similar process to the outer rim, where we have like you know, that we kind of take the same approach. So kind of drag that sketch out again, and then circular pattern, and select this outer perimeter, and again times 50. So now that we have the outer stator for like the outer rotating part, I should say, and the inner static part, that we can also put like the copper coils in this space right here. So, and like I said, I'm not going to go into very detail about how it will be coiled up and all of those, because there are computer systems that could literally like put the copper in place in different spots in different ways that you would get maximized electric efficiency and the least amount of heat being created and things like that. So I think that that is something to leave a little bit for the computer. So I'm just going to keep it a little bit as simple as I can, and later on like probably figure out how the computer would actually like solve it. And if there are other like engineers and designers working on this type of stuff that you would be interested in kind of collaborating on this and you have an idea on how to make this actually work, hit me up. I'm open for all suggestions. So that is also the next step to kind of implement the copper coils and everything in it. So you would basically again let's start from the top where we have like a good view again of all of it, and we select a new component, and in this component I want to kind of use this line to generate everything from. So we have this cube section right here, and I'm going to extend these just a little bit. So if you select this line and kind of put it on there, you kind of see the elongated pattern of where it's supposed to go. So I'm gonna do that and select 10 millimeters and kind of do the same on the opposite side. So and then again a cross section. Oh yeah, I need to extrude it all the way through. So here we have like what would be representative of what like a copper coil would be, because my computer will not take it to make 50 individual coils kind of look like that and everything. So that is going to be a little bit messed up. But one of the things that I'm going to do with it is that I'm going to also have like a little bit of an isolating sheet here. So I'm gonna take because like my whole thought process of this is gonna be that the copper and the iron are gonna be within one file that you can basically 3D print them. So it would be fully insulated and isolated also by this by all the I should say the iron pieces that will kind of stick out to isolate it. So here you'll now see, because I didn't put it at 305 but I put it at 295 millimeters in length, this whole coil unit, that it has like this space on the bottom. So I kind of want to drag it a little bit down. So let's see, this is a loose component now, and I can take it to have this bottom piece be selected to this surface, and then also select the sides, and then it will kind of be in place. That, but also I need to keep this inner radiator the same. Damn, that's the thing with components in assemblies, you kind of need to fix them in place, that if you don't want them to move away from each other, then they won't anymore. So if this component is supposed to be rotating based around where, yeah, so there we go. Then this can kind of rotate like that, and then you would have that system right there, and then this surface would be 5 millimeters away from that surface right there. So you can kind of select the distance that it needs to stay at, which would be 5 millimeters in my case. And then you will have like a 5 millimeter separation on either the top and the bottom section. And within that 5 millimeter separation, I now kind of want to go back to this the stator and edit component, select this top surface, and kind of select this inner loop right here. So let's see if this works. I think I should select all of them individually, but this is kind of the inner section of where the iron coils would be spinning around, I guess. And I want to extrude that to the other section, so it's again going to be 305. But as it is part of the rest, it kind of doesn't need to be like individually laid. So next will be a circle that is also on the bottom right here, but has this going towards like the middle point right there. So if you would put that in place and also drag it to about the 5 millimeters in that direction, you can kind of isolate those cores from one another. So I should also put this in like a circular thing, but also do that on the other side too, so you would have that same surface on the top and the bottom section. And one of the things with SolidWorks is that you can copy a sketch that you used earlier and put it on another layer. So if I just select this sketch and click on convert entities, then the same sketch I used on the bottom will now also be viewed on the top, and then I can do the same thing to it to have it drag out for 5 millimeters and going inward. And then also use the circular patterns to kind of use and to feature like this part that we put, that is going to be like the inner part of the coil, to have it also rotate around that circle 50 different times. And now it is acting up because it is kind of seeing zero thickness geometries, I guess. So what we can do is also kind of take those off, the top and the bottom circle that we used to attach everything, and then kind of do the same procedure because it won't come into contact with anything from this point. So it shouldn't really like have some intersecting problems. But there we go again. Geometry pattern, all bodies. What the hell? And if I now select bodies, okay, that's weird. But that is the way to resolve it, at least. But now you can see that these are now weird lines that are kind of intersecting with each other where they're not supposed to. So that is something that I'm also gonna fix. So if you then select all bodies, then it's kind of supposed to merge everything together again. And it already did it here, because if it's merged here, then it's supposed to be merged there. So one of the things that you might think when you see a shape like this, so that is also one of the things that I've learned about designing for 3D printing, is that in a regular situation you wouldn't be able to CNC or actually have like a mold that this shape would be physically possible, because you wouldn't have either a drill bit to go in here, or you would need to produce it out of a lot of different segments and stuff. But for this case, if you're talking about 3D printing, you could basically use whatever shape you want to, because you're no longer limited by production methods and things of that nature. So you would be able to have this whole you know, to have everything be just one component, and just to have the wires 3D printed around it, to have the conductive like magnetic poles and everything to change up. So that is one of the benefits that really comes with having a 3D printed software system or something like that, that you would be able to kind of use those things to have less and less components within assembly and everything, you know. So that is also one of the great benefits from it. And again, for this part, we're also gonna kind of use it to you know, have it go full 360 again, and select the bodies, which is usually the easiest way to do it. And then you would have again like all of the 50 coils in here. So if you would now take a look at like a section cut, you would have all of these coils that would be generating like magnetic fields and everything that are sitting in direct contact, not direct contact, but like in close proximity to the magnets that they're supposed to be in. So in this case, you would be able to, if it's rotating a little bit, you would be able to like put, if this would be like a negative or a negative magnet, I can't see the plus or the minus on it, but then you could put the electric current to be creating a negative current here, and then it would drag it into that direction and everything, and you would be able to do that individually for all of those modules. Yeah, and that would be then kind of generating the driving force for the car. And at the same time, if you don't put electricity in it, but it is rotating, so you would have like a situation where it's kind of rotating along like that, then you would be able to generate electricity with it, because all of those magnets would then be putting basically they would be putting their magnetic field, if it would be positive or negative, in that coil, and then that positive and negative would kind of create a flow of electricity again that would generate electricity. So then it is kind of used as a magnet, and in that way you can use it to brake, you can use it to accelerate, you can use it to generate electricity, or to use electricity and to kind of convert it into mechanical rotation. So that is how that would eventually be working. And on the outside you would have a tire, and here on the inside you would basically only have like the control mechanism for the wiring and everything. So with that being said, that is going to be the last thing that I'm gonna add to this video, and then I will be done. Is actually the coils to have input and output, because you would still need to have like the control units, as well as you know, that needs to be connected to one another to generate the magnetic fields. So also that would be something that could be 3D printed in place, that you wouldn't really need to have like a whole bunch of that you don't need individual wiring and stuff. But in this case I'm gonna just do it real quick, that I'm gonna put like a little bit of a wiring loom that's coming out of here, and then also do the same thing for the bottom side right there. So to make it look most realistic, I'm gonna take a plane. So select plane. Is anything happening? And as a reference, I'm gonna use this line right here, the edge, because from that point I can kind of take a sketch to kind of center that out. Let's also make a cut extrude right there, so I can take a sketch on that plane, and from the center make a circle. It's supposed to be like 1.25, I think. Yeah, and then I'm gonna drag that out for about 15 millimeters. And of course you won't be able to see it because of the cut extrude, but it is definitely there. And I'm gonna do the same also at the top, to kind of have a similar pattern going on. So again, select the plane, use kind of this sketch right here. But maybe beforehand I should even change the fillet up, because I put it at 120 to keep a little bit of a distance between here, to kind of attach the multiple layers to each other. But I think it's supposed to be 1.25, as I use the 2.5 millimeter radius. And then hopefully this kind of blends in smooth, and there you go. That wasn't the case on the previous one. So here we can kind of again go towards the sketch, but now because it is a perfect circle, I can also like do convert entities on that part and basically drag it along to a full circle, and then extrude it outward again at 15 millimeters. Easy. And then drag that down to have it in a pattern, and then you can kind of see that you have all of these attachment points where you have an input and an output for all of those electrical points. And that would then be kind of put through here, I think. So if I now go again out of the sketch and edit components on the inner stator, then I can eliminate a little bit of that outer material. So if I put like that at 5 millimeters and do a cut extrude, you can then see all of these points kind of sticking out. So what you can do with these points sticking out is kind of select one of them, click on cut extrude, and then convert entities. Actually cut extrude it all the way through. Is it even necessary to do it all the way through? I think it doesn't really matter too much. and then you can take that cut extrude and put it in a circular pattern, and then it will kind of come across from all of those coils, and then you just repeat the process at the bottom. So yeah, thanks for watching the first episode of me designing this 2040 design project that I'm working on. In the next video, I will be finishing up all of the details around this engine, so to have ball bearings to be able to connect these two without them actually like falling apart from another, to have the actual wheel rim, and to actually also have like a rubber tire that it is sitting on. And maybe I should even look at the differences in different tire manufacturing methods, that you don't even need to put air in there. And because I've seen some crazy stuff like that, so that people have like airless tires that already have some spring and dampening functions within it. I could maybe do something like that too. But yeah, that is going to be it for this episode. Thank you for watching. Stay tuned if you're interested in this content, and if you want to do a little bit more for it, or want to see more from it. And yeah, I will be uploading these daily. Like, I'm gonna just, as long as I'm in quarantine, basically like design stuff and just upload videos from the things that I make. So thanks for watching yet again, and I will be seeing you in another video. I'm out.